Welcome to the Conscious Tutor Year 2 program overview for number and place value. So there's 6 main objectives. The first one is counting in steps of 2, 3, 5 from 0 and in tens from any number forward and backwards. Next one is recognizing place value of each digit in a 2-digit number. Number 3 is to identify, represent and estimate numbers using different representations. So we'll look at those 3 first. So counting in steps is basically 2, 4, 6, 8, etc. 3, 6, 9, 12, 5, 10, 15, 20. So that's your 2, 5 and 3 times tables, but in year 2 it's introduces counting, so introducing that repeated adding. You can have missing sequences like something 4, 6, 8, something something 9, 12, something 18. So children work out what is the missing number. When it comes to tens, that's counting from any number forwards and backwards. So going back could be 90, and then there could be a couple of spaces, missing out 80 and 70, and then showing 60, 50, 40, 30. And that could be the same going forward as well. With tens, you can start from any number. So counting in tens from 16, 26, 36, 46, and backwards. And this is why knowing or having 100 square available is quite important, so that children can see that when you go down in 100 square, you can see that you're making a jump of 10 each time. The language that comes up again is 10 more and 10 less. So knowing that, building upon the year 1 language as well, fewer than, more than. The next objective is to recognize the place value of each digit in a 2-digit number. So although in year 2 children need to know, be able to read and write numbers to at least 100, the place value knowledge that they need to have is just for 2-digit numbers, tens and ones. So the number 26 would be partitioned, for example, into a place value grid of tens and ones. That's 2 tens and 6 ones, and that would be 20 and 6. And then you can also represent that in a different way, such as sort of like a tree diagram where you're splitting that up into an addition statement, but also as a bar model, so 20 being larger than the 6, and then combined that whole bar is 26. A bar model is quite a popular way of working out calculations as well. Pictorial representations is still important and a good foundation. So knowing, so children in schools will have lots of practice of using bars that have been divided up into 10 sections. These are Dean's equipment, and little Unifix cubes or yellow Dean cubes as well, which you can find in schools. So that's how you would draw the number 26. Also, the third objective is to be able to represent and estimate numbers using different representations. So you could have something like an empty number line with just 2 numbers written on it. Could be 0 to 10 or 0 to 50, 50 to 100. Here we've got an example of 0 to 100, and the question is, where would you find the number 50? So where would you find the number 86, or where would you find the number 10? So really being able to spot those key intervals on a number line is quite important. You might have to estimate numbers. For example, if we just quickly draw up a marble jar or something like that, you might be asked estimate how many numbers or how many marbles there are in the jar. So that's knowing where the children can sort of look at the bottom line and give a rough idea of how many there might be. The last three objectives are comparing and order numbers from 0 to 100 using the less than, more than, and equal sign, reading and writing numbers to at least 100 in numerals and words, and then use the place value knowledge and number facts to solve problems. So ordering numbers from smallest to largest or largest to smallest, you might be given a selection of numbers: 17, 26, 50, 5, 3, 13, and having to put them in ascending order, so from smallest to largest, or descending order. You might also be given some cards like 5, 6, 2, and try to work out the smallest two-digit number that you can make from those three cards. Here we've got a simple number statement. 81 is less than, so you need to think of numbers that are larger than 81 to write in that second box. And then 4 is more than, and numbers that are greater than 4 to put in that box. With the equal number sentence, you have 8 plus 3, which is 11, but that could also be represented as 8 plus 3 equals 5 plus something, and then having to work out what that might mean. Reading and writing numbers. So what's been taken out from this objective compared to the year 1 objective is the pictorial representation. So it's expected that children will know how to draw these numbers visually if need be. So 88 would be written as 88 and 13 written as 13. You may be given a word and have to write that in numerals. And then finally, the use of place value and number facts is knowing really number bonds to 5. So know that 5 plus 0 equals 5, 4 plus 1 equals 5, 3 plus 2 equals 5, etc. And how that can be used to create problems. Same with number bonds to 10 and number bonds to 100.